Dear students, now we are going to see the subject linear integrated circuits, and the subject code is EC3451, and the topic is sine wave generators or oscillators. On completion of this sine wave generators or oscillators, the students will be able to explain the condition for existence of oscillation and different types of oscillators and multivibrators. Sine wave generators or oscillator. The sine wave oscillators are based on op-amp and feedback loop of RC network provide 180-degree phase shift between the output to input. The oscillator principles and condition for existence of oscillation are: an oscillator is a feedback amplifier in which a part of output is fed back to the input via the feedback circuit. The circuit produces alternating current or voltage if the signal feedback is of proper magnitude and phase. Some oscillator, general oscillator block diagram, summing junction, amplifier, then feedback circuit. Similarly, here the amplifier, the output is feedback to the amplifier input. From the block diagram, the difference voltage Vd equal to Vf, that is the feedback voltage plus input voltage. The output voltage V0 is equal to gain of the amplifier into the difference voltage Vd. Vf is equal to beta, that is the feedback factor into V0. V0 is the output voltage, Vf is the feedback voltage, and beta is the feedback factor. Substituting equation 3 and 2 in 1, Vd equal to beta V0 plus Vin. So Vd equal to beta AV Vd plus Vin. So Vd minus beta AV Vd equal to Vin. So Vin is equal to Vd into 1 minus beta AV. Substitute this equation 2 in 4. So V input is equal to V0 by AV 1 minus beta AV. The ratio V in divided by V0 equal to 1 by AV into 1 minus beta AV. So V0 output voltage to input voltage ratio is equal to AV by 1 minus beta AV. So assume 1 minus beta AV equal to 0. The ratio of output voltage to input voltage is equal to AV by 0, that is infinity. This equation 2 conveys the external input to the circuit is 0. The condition for circuit produces output. Its own is called oscillation. The total loop gain A beta is equal to 180 degree. The equation 8 represents two conditions. The magnitude of total loop gain is unity and the total phase shift around the loop is 0 or 360 degree. These conditions are called Barkhausen criteria for oscillation. Multivibrators. Multivibrators are regenerative circuit and are classified into three categories: bistable multivibrators, astable multivibrators, and monostable multivibrators. Astable multivibrators toggle spontaneously between one state and other without any external triggering pulse. It has a two quasi-stable state. The rate of transition from one to other is dependent on the RC circuit components. The general block diagram of a stable multivibrator and its output graph is shown in figure. The output of op-amp feedback to the non-inverting input terminal. The resistor R1 and R2 form a voltage divider network, and a fraction beta of the output is feedback to the input. The fraction beta is given by beta equal to R2 divided by R1 plus R2. The reference voltage is beta V0 may take value as plus beta V saturation or minus beta V saturation. The output is feedback to the inverting input terminal after integrating by RC low pass filter terminal. If the inverting input terminal voltage exceeds the reference voltage, the switching takes place, result as square wave output. Initially, the circuit output is plus V saturation. The capacitor starts charging toward plus V saturation via the resistance R. The voltage at non-inverting terminal is at beta V saturation as represented by the use of R1 and R2 potential divider network. This condition continues until the capacitor voltage exceeds beta V saturation. voltage at the inverting input terminal becomes greater than the reference voltage, the output is driven to minus V saturation. Thus, voltage B plus beta V saturation across the capacitor starts discharging via the resistance R and charging towards minus V saturation. The capacitor voltage increases more and more negative and exceed minus beta V saturation. The output switches back to plus V saturation and the cycle repeats. The voltage across the capacitor as a function of time is given by Vc of t equal to Vf plus Vi minus Vf into e power minus t by Rc, where Vf is the final value, which is equal to plus V saturation, and Vi is the initial value, that is equal to minus beta V saturation. Substituting the above in equation 1, Vc of t equal to plus V saturation plus of minus beta V saturation minus V saturation into e power minus t by Rc. Vc of t equal to plus V saturation minus V saturation into 1 plus beta e power minus t by Rc. At t equal to capital T1, the voltage across the capacitor reaches beta V saturation and switching takes place. Vc of T1 equal to beta V saturation, that is equal to plus V saturation minus V saturation into 1 plus beta into e power minus T1 by Rc. Beta V saturation equal to plus V saturation into 1 minus of 1 plus beta e power minus T1 by Rc. So V saturation into 1 plus beta e power minus T1 by Rc equal to V saturation minus beta V saturation, that is 1 V saturation into 1 minus beta. So 1 plus beta into e power minus T1 by Rc equal to 1 minus beta. So e power minus T1 by Rc equal to 1 minus beta by 1 plus beta. Take natural logarithm on both sides of this above equation. So minus T1 by Rc equal to ln of 1 minus beta by 1 plus beta. T1 is equal to minus Rc ln of 1 minus beta by 1 plus beta. T1 can also be represented in terms of a logarithmic function, that is Rc ln of 1 plus beta by 1 minus beta. The above equation gives only one half period. The total time period is given by t is equal to 2t1. So t is equal to 2 Rc ln of 1 plus beta by 1 minus beta. The above equation can be written as t is equal to 2 Rc ln of 1 plus beta by 1 minus beta equal to 2 Rc ln of R1 plus 2 R2 divided by R1. Hence, the frequency of oscillation is given by f naught is equal to 1 by t, that is equal to 1 divided by 2 Rc ln of 1 plus beta by 1 minus beta. If R1 equal to R2, then beta equal to 0.5 and time t is equal to 2 Rc ln 3. So, f naught is equal to 1 divided by 2 Rc ln 3. Therefore, f naught equal to 1 divided by 2.2 Rc. The peak-to-peak amplitude can be varied by varying the power supply voltage. The general circuit diagram of asymmetric square wave generator is shown in figure. Here the output of the circuit is connected with the back-to-back connected Zener diode. The output voltage is regulated to plus or minus Vz plus Vd by Zener diode. The output voltage V0 is equal to 2 into Vz plus Vd. The current drawn from operational amplifier is given by ISC equal to V saturation minus Vz divided by RSC. An alternate method to get asymmetric square wave output is to add a DC voltage source in series with resistance R2. Now the capacitor swings between the voltage level plus beta V saturation plus V and minus beta V saturation plus V. A stable multivibrator is also called free running multivibrator. Summary: when V naught is equal to V saturation, The capacitance charges from minus beta V saturation to plus beta V saturation and switches the output to minus V sat. When output is equal to minus V sat, the capacitance C charges from plus beta V saturation to minus beta V saturation and the switches output voltage to plus V saturation. Possible quiz question. How are the square wave output generated in op-amp? In op-amp is forced to operate between positive and negative saturation region. Thank you.